Ma'am, please
Can you hear
unmute
me?
yourself.
Yes, yes.
Yes, ma'am.
Muted myself. All right, very good. I'm very sorry today. I seem to have bad connectivity, which hardly ever happens. Okay, so this is an immature skeleton. Now remember that. Excellent. What are we next? Come on now, quickly. Zara. Lopa, what are we seeing? You there, Zara? I think Zara might have got logged out or something. All right, let's ask Hema. Come on, Hema. Hema, can you hear me? Hema, you're muted. Hema, you're muted.
Dr. Hema, please unmute yourself.
Team, hello? Hello?
Yes, Hema, a little louder.
Hello?
Oh, okay, Zara, you're back. Come on, Zara.
Ma'am, this section is showing sheets of tumor cells.
Loudly, Zara.
Ma'am, it's showing sheets of tumor cells in a chondroid matrix.
In a chondroid matrix. No, I don't know that you can say it's a chondroid matrix.
Ma'am,
Yes,
in the
sheets, very
cartilage.
cellular sheets. Yeah, there are
The
some
cartilage.
areas of cartilage that you are seeing. There is bone as well. Okay,
Ma'am.
very good. So that's what you see at low power. Now, what do you see here in the cellular areas?
Ma'am, it is cellular and the cells are oval to polyhedral in shape and have abundant eosinophilic cytoplasm.
Okay.
Ma'am, and there
Very
are
good.
bizarre atypical nuclei which display an
Bizarre or atypical nuclei. Do you see bizarre and atypical nuclei? What do you mean by that, Zara? This is even higher.
Ma'am, the shape,
The
some
shapes,
of
they're not
the,
bizarre. You know what is the meaning of bizarre, Zara? That they are out
not
of this world. That's what bizarre means. Okay. To me, this looks fairly monomorphic, except that there is some irregularity of the nuclei. Yes. Hema, you agree?
Ma'am.
Yes. Okay. But you see that the irregularity again seems to be that there are these notched. Can you see that the nuclei are notched?
Yes, ma'am.
Like we saw in the first case, that was very evidently crescentic. But these nuclei are irregular. Some of them are definitely notched. Okay?
Yes.
But there's something else that we see.
Ma'am, there's pericellular lace-like calcification around the
Yes, around each cell. You see the box-like cells, and there is an accentuation of the box-like nature with this calcification. Okay?
Yes, ma'am.
And this is another area where there isn't calcification, but you see the myxochondroid stroma in between. Yeah, you see that. In some
Yes.
places, there is some chondroid, but there is no hyaline cartilage. Sometimes you do see the hyaline cartilage, but that hyaline cartilage might arise from the epiphysis and where this tumor is situated. Okay. So what is your diagnosis now?
Ma'am,
This is easy.
ma'am, it is a chondroblastoma because
a
of the peculiar
chondroblastoma.
chicken wire appearance.
Fantastic. Excellent. Yes. So you saw the tuberculation, some little bit, fragments of a cellular tumor, and you saw this. Yes. So this is a chondroblastoma. Now, somebody asked me a very interesting question in the chat box. Is there anything that can help you to tell the difference between a clear cell chondrosarcoma and a chondroblastoma? Because they can look extremely similar. Okay. The answer is yes. And here is another histone mutation, another protein that is, being made by a mutated histone. Okay. And these are known as mutation specific proteins. So what do you mean by mutation specific? We saw one that was specific. It was a G34, H3.3 G34M mutation, specific protein for a giant cell tumor and a malignant tumor that arises from giant cells. So benign giant cell tumor and a malignant giant cell tumor that arises from a giant cell tumor has a mutation-specific protein. Here, for chondroblastoma, there is a mutation-specific protein. And wherever a chondroblastoma occurs, and sometimes you get rare sites for a chondroblastoma, including on the surface of bone, they will all express this H3K36M. So what are these mutation specific proteins which arise from histones? Now, if you don't know what a histone is, 2 minutes, I will tell you what it is. You know that you have DNA and it is a thread-like thing and it has to be compressed. You know that DNA is a very huge molecule and people tell you all sorts of things that you can wind it around the earth and all sorts. But whatever it is, the molecule is very long and it has to be compressed into chromosomes, and all of these have to be compressed into the nucleus of a eukaryotic cell. Now, the DNA winds around itself and then is wound around what we call histones. Now, these histones have a very important role to play, not only for winding these proteins around, but also in how they control transcription of the genes that are present in the DNA that is wound around them. So the histones are present in what are known as nucleosomes. And when the nucleosome has one histone, it's called H1, that binds this together to the nucleosome, that is known as a chromatosome. Don't worry about that. Just remember that these are histones, and histones are present in the nucleosomes. And around this, you have the ball, like a ball of twine that is wound around these basic proteins. You know that DNA is an acidic molecule, and histones have got a basic character which attracts this DNA which winds around it. All right. So this is a nucleosome. You have the DNA. You have 8 of these histones. H1 is not considered as one of the 8 in the nucleosome. It's just like a plaster that sticks the DNA to the nucleosome. You start with H2A and H2B, so 2 H2As and 2 H2Bs and 2 H3s and 2 H4s. So altogether you have 8 of these histone, and these the histone is a protein. Okay, please remember that. The DNA that's winding around it is composed of nucleotides. These are composed of amino acids. So they are proteins. And these proteins have a very interesting shape. You see, they have little tails that stick out from this. You know, literally, you could hold it up like a little balloon with its string. That's what a histone protein looks like. It is sitting inside the nucleus around which DNA, which is acidic, is wrapped. And this is just to tell you that if that DNA is bound loosely around the histone, and how does it how does it bind loosely? It's because the histone gets acetylated. So if an acetyl group or groups are added to the histone, then the DNA cannot bind as tightly as it would if the histone did not have the acetyl groups. Okay, so you have histone deacetylases and you have histone acetyl transferases, and these enzymes actually regulate whether DNA is being transcribed or not being transcribed. So that's how histones control DNA transcription. But now let's talk about oncohistones, okay? And I'm showing you these 3 oncohistones. What we have been using for the longest time, one of the histones, and you use it in CNS work. We also use it in malignant peripheral nerve sheath tumors, that this is the K27 region of the histone. It gets mutated and This is, I'm talking about the gene gets mutated and then this particular part of the protein is lost. And therefore that histone is not expressed in those tumors. So it's not expressed in some kinds of CNS tumors, and it is not expressed in many malignant peripheral nerve sheath tumors. So the mutation causes the loss of expression of the protein. On the other hand, you saw today two histones. Okay, one was G34, again on this H3. So it is this tail of this protein, okay, H3, where the mutant gene has produced a mutant protein with G34 being expressed as a mutant protein in the tumor cells. And you saw that in giant cell tumor of bone and in chondroblastoma when it was K36. Okay, so you have to remember this. K27, G34, K36, all on histone H3 protein. So you saw that, and the answer to the question that somebody asked, you now know that in a clear cell chondrosarcoma, you do not get the mutation specific protein that you see in chondroblastoma of bone. Okay, so now that I've told you about these histones, I think I finished this slide seminar. If there are any questions that anybody would like to ask, I'm very happy to answer. But more than anything else, I want to say how terribly happy I am at the way that all these young students have interacted. Okay, I just put this up here that, you know, about appearances can be deceptive. Each one of these was a epiphyseal tumor. Each one of them appeared to be absolutely slow growing or benign, and two of them turned out to be malignant. Yes, one of them turned out to be a chondroblastoma. Okay, so we keep saying that we must correlate what we are seeing with the X-rays, but ultimately we have to believe the evidence of our eyes. Okay, and we know, everybody knows, including the radiologists, that they can only make diagnoses based on experience and not on the rare tumors that one may see. All right. So now that's the end of my talk. I think I will stop sharing. Yeah. And so if there are any questions, I would be happy to answer them. Would you think of them later? Please send me an email. And some people have been sending me emails, and I'm always happy to receive them. Okay. So anything in the chat
Rayas
box that
has the
anybody wants to
question, I
know?
guess.
Yes. Who has a question? Who has?
Rayas has? Rayas?
Yes, ma'am.
Prayas, you have a question? Oh, wonderful. He put up his hand. I like Prayas because he's always putting up his hand. Yes, tell me, Prayas.
I have a question, ma'am. How can we differentiate, ma'am, the giant cell osteosarcoma from secondary malignant giant cell tumors?
Well, you can't unless you know that there is a giant cell tumor that has occurred before in that region. That's number one. Number two, giant cell osteosarcomas do not occur in the epiphysis. Giant cell osteosarcomas, the routine giant cell osteosarcomas occur where osteosarcomas normally occur. So where do they normally occur? Prayas, osteogenic sarcomas, where do they occur?
Metaphysis.
Yes. So the problem only arises when you have a tumor that is sitting in the epiphysis, yes, and you are not sure now whether this is a giant cell tumor which has turned malignant, or there was a giant cell tumor and now it is malignant, or it is so large that it has, it may have started in the epiphysis, but now it has involved the metaphysis, etc. Okay, then you have a real issue. Okay, now then the next thing that you do is you ask what is the age of the patient. Okay, most of our osteogenic sarcomas occur at the age that is young adults and teenagers. Yes, that's where, and that's the age at which they occur. You have a 35-year-old or you have a 40-year-old and you have a giant cell rich lesion which is large, which is an osteogenic sarcoma, then you have to think, you have to think very hard. Now, fortunately for us, we have a antibody, and with that antibody, I don't have the problem anymore. I just put that antibody on. It is a mutation-specific antibody for giant cell tumor, and that's it. But everybody cannot have the mutation-specific antibody, and so we have to have some guidelines. And what are the guidelines? Where is this tumor? Is it in the epiphysis? Is it in the metaphysis? What is the age of the patient? Is this a mature skeleton? Is it an immature skeleton? And then you can have a really more focused diagnosis. Ultimately, remember that an osteogenic sarcoma has to be treated as an osteogenic sarcoma. Its prognosis and its response to treatment will vary with whether it came from a giant cell tumor, which has become an osteogenic sarcoma, then that doesn't do very well, or it is primarily a primary osteogenic sarcoma of bone, which is the usual type in the metaphysis. Yes. So do you get the answer to my question?
Thank you.
Did you get the answer to your question?
Thank you.
Satisfied, Prayas?
Yes, ma'am.
Very
Thank you.
good. Somebody has asked a question, is the mutation-specific antibody also positive in giant cell osteogenic sarcoma? I think I answered the question, right? If it is arising from a giant cell tumor, then yes, it will be. If it is just any old giant cell osteogenic sarcoma, it will not be positive, okay? Now, what is this? Is both H3, F3, G34? Yes, it's the same thing. Yes. The G34 is G34. Okay. Then, anybody else? Somebody, Madhuri Shah says, approach to diagnosis of chondrogenic and osteogenic tumors. I think that has already been taken for you in 2 major lectures. I cannot, in the space of this, I just showed you chose lesions that were in the epiphysis, which looked similar, and how chondroblastoma could be mistaken for a clear cell chondrosarcoma, and giant cell tumors could be also showing you giant cell and osteogenic sarcoma, and just gave you an introduction to what we are calling oncohistones. Anybody else has any other questions? What is this? Somebody said malignant GCT. What? Will somebody with who is from 3? I don't know who 3 is. What do you mean about malignant GCT? A malignant giant cell tumor is a malignant giant cell tumor, okay? And that, yes, will whether it's an osteogenic sarcoma or just a malignant giant cell tumor, it will show you the histone, the positive, that means the mutation-specific mutation, all right? It will show you that particular protein. Not if it is just any old giant cell osteogenic sarcoma. It has to be related to the giant cell tumor of bone. And please, it is not the giant cells that show you that mutation at the protein. It is in the nuclei, okay? So it is in the stromal cells that you have to look for it, because the giant cells are not directly part of the tumor. And I hope you know that. You know all about rank L, and how giant osteoclasts are actually associated, or why osteoclasts are associated with the stromal cells in a giant cell tumor. Okay, right. Should pathologists interpret X-rays and CT scans? Of course they should. I don't think there is any prescriptions for doing that. And I know some very good surgeons who can look at histology and tell you what this is. So I don't see any reason why we should not. In fact, if we don't, I think we're doing ourselves and the patients a disservice. Because the more you look at these tumors and the more you are able to make diagnoses, you can pick up, discrepancies in bone. But you know why we also ought to know what this is all about? Suppose there have been 3 cases on one day being biopsied in a very busy radiology center, and they are mixed up. All right, and I am told that I have a giant cell tumor, that this patient has the radiology of a giant cell tumor. Okay, and I see a very frank, tuberculosis. So then I know, no, that this cannot be so. Because I'm seeing tuberculosis, and tuberculosis cannot look like a giant cell tumor or bone. So I have to be certain that this is that this particular material has not been mixed up. And I pick these kinds of things up every month. I pick up 1 or 2 things that have been mixed up somewhere else and then sent for a second opinion. Okay. Any other? No? All right. So I think now we can all go to dinner. Thank you very much, all of you,
Thank you so much.
Thank you, ma'am.
Thank you, ma'am.
Emma and Zara and Mansi, and we have Monica and Prayas and Sarangi. I think all of you did extremely well today. We cannot know everything, and